Right, now let's say you've got some field and you've got some terrible smelling things in this field, and you don't want to get anywhere near them. And these are the two things that really don't smell very nice. And you want to try to work out how to walk from this part of the field to the other part by not getting anywhere near these two. Now, let's say that you walk like this. Well, as you walk, then you're getting closer and closer to this thing, and you want to make sure that you want to stay as far away from that as possible. So we've got to try to work out the path that is equidistant between the two lines. So if I draw a line between them like this, if I were to draw a line that's equidistant between these 2 points, then it's going to be the same distance between points, let's call it point A and point B, at any time. So if I were to draw a line like this and pick a point, let's say here, that would be much closer to B than it would be to A. So then that wouldn't make sense to put it there. The way that you can draw this accurately is to use a compass. So if you pin the compass at one point and you open it a bit more than halfway, let's say 3/4 of the distance to the other point, and we draw a little arc. Let's do the arcs in red. So I'll draw an arc above it and I'll draw an arc below it, like this. And I'm going to repeat the same thing on the other side of the line. So I'll just cross those 2 points now. Remember, if you don't cross the 2 points, if you've drawn the first arc, let's say over here, you just make it long enough so that you can cross the two. So then I'll draw the other one down here. You've got to have 2 crossing points for this to work. But you've also got to remember to keep the compass open the same distance as you did from the other point. That's very important. So now I've got my 2 crossing points. I can use a ruler to draw between them. So I could draw a line straight through like this. Then wherever I decide to go on this red line, if I pick a point, let's say here, then that distance will be exactly the same as that distance. So anywhere on this line will be equidistant between the two ends of this black line. And this line here is called a line bisector, because I've actually ended up by cutting this black line in half exactly. And also, interestingly, it's at 90 degrees. So this line is 90 degrees, it's perpendicular to this line, and anywhere on this line is equidistant, and the line is called the line bisector.